These problems all involve multiplying together radicals, and I mean things under this square root sign, and then simplifying them. This can be a tricky thing to catch on to, so if it seems confusing at first, stick with it, do some practice problems. I'm sure you'll get it. The trick here, the secret, is that you can factor out things inside the radical sign and then separate them apart. So for example, if I had the square root of 28, I know that 28 is 7 times 4. So I could rewrite that as the square root of 7 times 4. And I could rewrite that as the square root of 7 times the square root of 4. Oh, and I actually know what the square root of 4 is. That's 2. But when we write answers like that, we usually put the whole number first and the radical second. So I would write this as 2 times the square root of 7. That's the same thing as 28. So there's this process of factoring and seeing if you can find anything that you can take the square root of. Let's see what we have in this problem. A square root of 7 times the square root of 35. Well, I can factor the square root of 35. So we've got our square root of 37. The square root of 35 is the square root of 7 times 5. And that means that the square root of 7 times 5 can also be written as the square root of 7 times the square root of 5. And this is good news, because we have 2 square roots of 7, and they're multiplied by each other, which means it's the square root of 7 squared, which is just 7. Whenever you get 2 square roots like that are multiplied together, it just becomes the number. So this is 7, and then what we have left over is our square root of 5. So our answer is 7 times the square root of 5. All right, let's try a couple more. So 11 times the square root of 33. Well, 11 I can't do much with. That's a prime number. 33, though, I know is 3 times 11. Oh, and that's a good sign. We've got an 11 in there. So I could rewrite this as square root of 11 times the square root of 3 times the square root of 11. These two together make 11. Square root of 11 times square root of 11 is just 11. So this comes out to be 11 times the square root of 3. All right, let's try this next one. A little more complicated. We have 4 times 180 times 6 times the square root of 2. Well, let's just start factoring 180. What can we do with that? Well, 180 is 18 times 10. And, 18 is 2 times 9. So this is 2 times 9 times 10. And let's see, we've got 6 times the square root of 2 out here. Let's see if I can go further here. Well, I like the 9 because I know how to take care of the square root of that. So I'm going to rewrite this as 4 times the square root of 2 times the square root of 9. And square root of 10 is actually the square root of 2 times 5. So I'm going to write that as times the square root of 2 times the square root of 5. And then we've got our times 6 times the square root of 2. Okay, we're getting there on this one. I'm going to start simplifying. This 9 can become a 3. The square root of 9 is 3. And then we've got 2 square roots of 2. So that becomes a 2. So starting out front, I've got 4. Now I've got this 3. Then I've got this 2. That leaves, I've done this. That leaves the square root of 5. And then I've got times 6 and times the square root of 2. So let's see. 4 times 3 is 12, times 2 is 24, times 6 is 144. And what I'm left over with then is the square root of 5 times the square root of 2. I can't really do anything with either of those. They're both prime numbers, no more factors to take out. So what we do is we just multiply them back together. The square root of 5 times the square root of 2 is the same thing as the square root of 10. So this becomes 144 times the square root of 10. A lot of work on that one, but we got there. All right, let's try one more with another added level of trickiness. Here in the parentheses, we actually have 2 terms and then another term on the outside. So we're going to have to distribute this term. So that's 6 times the square root of 2 times 8 times the square root of 6 minus 6 times the square root of 2 times 5 times the square root of 8. Let me just write out what I just said. So we have 6 times the square root of 2 times 8 times the square root of 6. and then a minus sign, and again 6 times the square root of 2 times 5 times the square root of 8. All right, let's start seeing what we can simplify. This 6 I know is 2 times 3, and I think that's going to help us out. So this is 6 times the square root of 2 times 8 times, and this will be square root of 2 times the square root of 3. And then over here, let's see what else we can do. We have 6 times the square root of 2, not much to do there, times 5. And the square root of 8, well, that's the square root of 2 times square root of 4. So, because 8 is 2 times 4. So we can write that as square root of 2 times the square root of 4. All right, that's looking better, because I know what to do with the square root of 4. That becomes 2. We've got 2 square roots of 2. That also becomes a 2. And then we've got 2 square roots of 2 here. That becomes a 2. So let's start putting all this together. Now I have 6 times 2, and I've got that 8. And we've dealt with all of that. And then I just have that square root of 3 left over that I couldn't do anything with. And then I have my minus sign. And then here I have 6. And then I have this 2. I have this 2. And I have this 5. And I think that got rid of everything. Okay. So let's multiply back together what we can. 6 times 2 times 8. So 12 times 8. What is that, 96? Times the square root of 3. And then 6 times 2 times 2 times 5. So that is 10 times 12, so 120. So the answer I got there, I might want to check all my math on that one, just in case I messed up. But I got 96 times the square root of 3 minus 120. And that's a little bit of work with simplifying radicals.